Somewhere in the dark water of the constellation Cetus, a galaxy is shining from a wound at its center. From far away, Messier 77 can look almost gentle. A spiral of starlight. A faint oval with arms curled around it like something sleeping. Through a small telescope, it is a quiet blur. Through older photographs, it looks like one more island universe, one more distant city of stars, suspended in blackness. But the center is not quiet. At the heart of this galaxy, gas is falling toward a black hole with the mass of millions of suns. It does not fall politely. It does not vanish in silence. It piles up. It heats. It shears itself apart. It becomes a storm of radiation and dust and magnetic fields, wrapped around an object that no telescope can see directly, yet whose presence is written across the entire galaxy. This is the strange thing about galaxies. We often imagine them as shapes, spirals, ellipses, bars of light, beautiful objects on a screen. But a galaxy is not a picture. It is a living structure, not alive in the biological sense, not alive with intention, alive in the physical sense. It moves, it feeds, it hides itself. It forms stars, buries stars, tears gas into filaments, and sometimes lets a black hole at its center burn so brightly that the nucleus outshines billions of suns. Tonight on Dark Matter Radio, we are going to sit with one galaxy in particular, Messier 77, NGC 1068, the Squid Galaxy. A barred spiral galaxy, roughly 45 to 47 million light-years away, close enough for astronomers to study in detail, far enough that its light began traveling toward Earth when our planet was still a very different world. The recent Webb image of Messier 77 is beautiful. That is the first thing anyone notices. A luminous core, curling dust, soft arms, a strange geometry of light around the center. But beauty is not the reason this galaxy matters. It matters because it shows us something we often forget. The universe is not still. A galaxy can look frozen because the timescales are too large for a human life. A spiral arm does not visibly twist while we watch. A cloud of dust does not rearrange itself between one night and the next. The stars seem fixed. The core seems fixed. The whole structure seems like a cosmic emblem, something engraved into darkness. That is an illusion created by our short lives. Inside Messier 77, gravity is sorting matter every second. Gas clouds collide and compress. New stars are born in regions wrapped in dust. Older stars drift through the disk on slow orbits measured in millions of years. Near the center, material loses its calm. It spirals inward toward a supermassive black hole, not because the black hole is swallowing the galaxy whole, but because some matter has wandered too close to a region where ordinary motion becomes a machine for heat. A black hole does not need to eat much to change everything around it. That sentence is easy to say, but it is worth sitting with. A black hole itself is dark. By definition, no light escapes from inside the event horizon. If a black hole were alone in empty space, it could be almost invisible, a hole in the rules of geometry rather than a lamp. The brilliance comes from the neighborhood, not from the hole. It comes from gas and dust before the final fall. It comes from matter, rubbing against matter, orbiting faster, compressing tighter, heating until it radiates across wavelengths our eyes were never built to see. Messier 77 is one of the classic examples of an active galaxy. Its center is not just a dense cluster of stars. It is an active galactic nucleus, often shortened to AGN. That term can sound sterile. It sounds like something from a catalog. But the idea behind it is almost mythological. A whole galaxy with a furnace in its heart. A central engine powered by gravity. A region so bright and compact that it forces astronomers to ask what could possibly release that much energy from so little space. For much of human history, galaxies were not even known to be galaxies. Messier 77 was first noticed in the 18th century, when telescopes were still modest instruments and the sky was being mapped by patient observers. Pierre Messier saw it, and Charles Messier added it to his catalogue of objects that were not comets. That catalogue was practical. Messier wanted to avoid confusion. Comet hunters needed to know which fuzzy objects did not move, so he listed them: nebulae, clusters, blurs. The name Messier 77 is a remnant of that older sky, when the universe beyond the Milky Way had not yet been measured. Imagine looking at a faint smudge and not knowing whether it was a cloud inside our own galaxy or another galaxy entirely. That uncertainty lasted a long time. The scale of the universe had to be forced open. Telescopes had to grow. Photography had to improve. Spectroscopy had to reveal that starlight carries fingerprints. Edwin Hubble and others had to show that many spiral nebulae were not nearby gas clouds, but separate galaxies, immense systems beyond the Milky Way. What looked like mist became architecture. What looked like background became distance. Messier 77 was no longer a blur. It was a barred spiral galaxy in Cetus, the whale, with a structure large enough to hold billions of stars. But even that was not the end of the story. The more astronomers looked, the stranger the core became. Some galactic centers are sleepy. Our own Milky Way has a supermassive black hole, Sagittarius A star, with about 4 million solar masses. It is not dead. Nothing like that is dead. But compared with many active galactic nuclei, it is quiet. It flickers. It feeds a little. It gives off flares. Yet it does not dominate the entire galaxy with overwhelming radiation. Messier 77 is different. It is classified as a Seyfert galaxy, named after the astronomer Carl Seyfert, who studied galaxies with unusually bright nuclei and strong emission lines in their spectra. Those emission lines were clues. They revealed gas moving at high speeds, energized by intense radiation. A Seyfert galaxy may look like an ordinary spiral from the outside, but its center is doing something extraordinary. The galaxy still has arms. It still has stars. It still belongs in the family of spiral galaxies. Yet its nucleus behaves like a separate machine, compact and ferocious. This dual nature is part of what makes Messier 77 so compelling. It is not a remote quasar at the edge of the observable universe, so distant that it becomes almost abstract. It is not merely a local galaxy with a dim center. It is close enough, in cosmic terms, that astronomers can study structure, dust lanes, star-forming rings, gas motions, the buried engine. It is a nearby laboratory for understanding a phenomenon that appears across cosmic history. When Webb looks at Messier 77, it is not only taking a picture of one galaxy, it is helping us understand what happens when galaxies become engines. The James Webb Space Telescope was built for infrared light. That matters because dust is not just decoration in space. Dust is one of the great filters of the cosmos. In visible light, dust blocks and scatters. It hides young stars. It darkens lanes across galaxies. It turns simple shapes into silhouettes. But in infrared, many dusty regions become more transparent, and warm dust itself glows. Webb does not simply see farther, it sees differently. Human eyes are narrow instruments. They sample a small strip of the electromagnetic spectrum, the part we call visible light. But the universe does not limit itself to our eyes. A star-forming cloud can be opaque in visible light and bright in infrared. Hot gas can announce itself in X-rays. Cold gas can whisper in radio waves. Dust can absorb one kind of light and re-emit another. To understand a galaxy, astronomers need to listen across the whole orchestra. Webb gives us infrared hearing. That is why images from Webb often feel as if a veil has been lifted. They are not simple photographs in the everyday sense. They are carefully processed views of infrared data, translated into colors our eyes can interpret. The colors are real in the sense that they correspond to measured wavelengths, but they are not what a human astronaut would see floating nearby. They are maps of energy, maps of dust, maps of temperature and structure. In the Webb image of Messier 77, the core is bright because gas is being pulled by the black hole's gravity into rapid motion. The light around it is not the event horizon glowing. The black hole remains black. The brightness is the punishment matter pays for getting close. The surrounding gas is forced into orbits so fast and tight that friction and turbulence turn gravitational energy into radiation. Gravity is not only a force that pulls things down. It is a way of extracting energy from falling matter. You know this from ordinary life. Water falling through a dam can spin turbines. A dropped object can break what it hits because gravitational potential energy becomes motion. Around a black hole, the same principle becomes extreme. Matter falls inward, but because it has angular momentum, it cannot simply drop straight in. It orbits. It spreads into a disk. Inner regions orbit faster than outer regions. Layers drag against layers. Magnetic fields thread through the plasma. Energy is released before the matter crosses the point of no return. An accretion disk can be more efficient at turning mass into energy than nuclear fusion in the core of a star. That is one reason active galactic nuclei can be so bright. They do not need to convert all their matter into light. They only need to extract a fraction of the enormous energy available as matter falls into a deep gravitational well. A supermassive black hole is not a furnace in the ordinary sense. It is a gravitational engine. But engines need fuel. Where does the fuel come from? This is one of the deeper questions in galaxy evolution. Gas in a galaxy does not automatically fall into the central black hole. Most of it orbits at a distance. Stars move through the galaxy without being swallowed. Space is huge, and black holes are small compared with their host galaxies. To feed the center, gas must lose angular momentum. It must be nudged inward. It can be disturbed by bars, spiral arms, interactions with other galaxies, turbulence, or instabilities in the disk. A barred spiral galaxy has a central bar of stars and gas cutting through its disk. Bars can help move material inward over long timescales. They are not conveyor belts in a simple mechanical sense, but they reshape orbits. They create gravitational patterns. They can guide gas toward the inner regions, where other processes take over. In a galaxy like Messier 77, the bar, the spiral arms, the circumnuclear structures, and the active nucleus are all parts of a larger story of matter, losing its distance from the center. The galaxy is not a flat painting. It is a gravitational ecosystem. This is why the phrase living structure matters. A galaxy is not alive, but it behaves like a system with metabolism. Gas comes in. Stars form, massive stars die, and return enriched material to space. Black holes feed. Radiation pushes back. Dust is created, heated, destroyed, and rearranged. Supernovae stir the gas. Magnetic fields guide charged particles. The shape we see is the visible trace of processes happening at many scales at once. A galaxy has weather. Not weather like clouds over Guwahati or rain crossing a valley. Galactic weather is slower, colder, larger, and more violent. It is the turbulence of interstellar gas. It is the pressure from newborn stars. It is shock waves from stellar explosions. It is radiation pouring from a nucleus. It is dust lanes collecting along spiral arms. It is the long rearrangement of matter under gravity. Messier 77 has all of this, and then it has something more. Its center is hidden. That sounds strange, because the image shows a brilliant core. But brightness is not the same as transparency. Active galactic nuclei are often wrapped in dust. In some directions, we see directly toward the inner hot region. In other directions, dust blocks the view. Astronomers developed what is called the unified model of active galactic nuclei to explain why different active galaxies can look different depending on viewing angle. The central engine may be similar, but the surrounding dusty structure changes what reaches us. In simple terms, the same kind of cosmic engine can look like different objects if you see it from different directions. Messier 77 is important because its core has long been used to test this idea. Observations have found warm dust near the center, arranged in ways that can obscure the black hole and its accretion flow. Visible light may not show everything. Infrared can help reveal what dust hides, because dust that blocks visible light can glow in infrared. That makes Webb an ideal instrument for the case. A hidden engine is more unsettling than a visible one. When something is visible, you can place it in the mind. A star shines, a nebula glows, a planet reflects. But an active galactic nucleus is partly known by its consequences: radiation, spectral lines, dust temperatures, gas velocities, structures carved by energy that came from a region too small and too buried to see directly. It is almost forensic astronomy. The event is not witnessed directly. The scene is reconstructed from traces. The bright lines radiating from the center in Webb's image are a useful warning. Not everything in an astronomical image belongs to the object. Some features belong to the telescope. Webb's famous diffraction spikes appear because of the shape of the telescope's mirror segments and the supports of its secondary mirror. They are optical artifacts, not physical beams shooting out of the galaxy. This matters because astronomical images invite imagination, and imagination needs discipline. A galaxy can be strange enough without adding false drama. The spikes are not the galaxy. The glow is not exactly the black hole. The colors are translated infrared data. The distance has uncertainties. The core is active, but not every bright line is a cosmic jet. Careful science often begins by separating what is real from what is instrument. That does not make the image less powerful. It makes it more powerful. Because once the artifacts are understood, the actual galaxy remains astonishing. A bright nucleus powered by falling gas. Dust lanes showing where matter absorbs and re-emits light. Spiral structure filled with star formation. A barred system whose gravity organizes the motion of billions of stars. A supermassive black hole shaping its surroundings without needing to consume everything. The universe does not become smaller when we remove illusions. It becomes sharper. Think of dust for a moment. On Earth, dust is a nuisance. It gathers on shelves, it floats in sunlight, it collects in corners. In astronomy, dust is both obstacle and archive. Cosmic dust grains are tiny, but collectively they shape what we can see. They are made from heavier elements, forged in stars, and scattered by stellar winds and supernovae. They contain carbon, silicates, icy coatings in some environments, and complex molecules. They absorb ultraviolet and visible light, warm up and radiate in infrared. Dust means the galaxy has a history. The early universe had hydrogen and helium, with traces of lithium. The carbon in dust grains, the oxygen in silicates, the metals astronomers speak of, all had to be made inside stars or in stellar deaths. So when Webb sees dust in a galaxy, it is seeing the residue of previous generations. Stars lived, changed the chemistry around them, and died. New stars formed from enriched gas. Black holes fed on material that had already passed through cycles of cosmic transformation. Messier 77 is not just a galaxy with a black hole. It is a recycling system on a scale that defeats ordinary intuition. A star is born from gas. It shines by fusion. If massive enough, it dies violently. Its death seeds the interstellar medium with heavy elements. Those elements become dust. Dust helps cool clouds. Cooler clouds can collapse more easily. Collapse can form new stars and planets. Some gas drifts inward. Some is expelled. Some gets caught in the gravitational politics of the galactic center. Eventually, a small fraction may join the accretion flow around the central black hole. The black hole is not outside the life of the galaxy. It is part of the circulation. This is one of the great shifts in modern astronomy. For a long time, black holes were treated almost as exotic endpoints, strange objects, mathematical monsters, places where matter went to disappear. Now they are understood as actors in galaxy evolution. Supermassive black holes correlate with properties of their host galaxies. Active nuclei can heat gas and influence star formation. Jets and winds can inject energy into surrounding material. The relationship is complex, and not every detail is settled, but the central point is clear. Black holes are not just endings, they are environmental forces. Messier 77 gives us a nearby example of that principle. It lets astronomers study how a central engine interacts with dust and gas in a spiral galaxy. It is close enough to reveal structure, bright enough to stand out, and obscured enough to teach us how much can be hidden even in a famous object. There is a lesson here about appearances. Most people, seeing a spiral galaxy, think of calm. The Milky Way in photographs looks serene. Andromeda looks serene. Spiral arms suggest order. The word galaxy itself has become almost comforting. It appears on posters, wallpapers, phone screens, meditation videos. A galaxy is used as a symbol of wonder, a peaceful thing. But the peace is mostly distance. Move closer in thought, and the calm dissolves. Spiral arms are not fixed arms like the arms of a pinwheel. They are density waves and patterns in a disk of stars and gas. Stars pass through them. Gas compresses. Star formation increases. Young, hot stars shine brightly and die quickly. Supernovae explode. Dust lanes mark places where matter is thick and cold. The beautiful spiral is a trace of instability managed by gravity. At the center, the illusion breaks completely. The nucleus can host dense star clusters, gas clouds, magnetic fields, and a black hole millions or billions of times the mass of the Sun. The region may be tiny compared with the galaxy, yet it can dominate the energy output. This is one of the strange facts of scale. A small central zone can make itself known across tens of thousands of light years. A city may be quiet from orbit. A galaxy may be quiet from a poster. That does not mean nothing is happening inside. The Webb image of Messier 77 arrives in a time when astronomy is changing from cataloging objects to watching systems. Not watching in real time, usually. The timescales are still vast. But watching in the sense of understanding process. A galaxy is no longer just a type. It is a history. A set of flows. A record of formation, collision, feeding, feedback, and chemical change. The phrase feedback is common in astrophysics. It means that the output of one process affects the conditions for another. Stars form from gas, then massive stars produce radiation and winds that can heat or blow away nearby gas, slowing further star formation. Supernovae can disrupt clouds, but also compress other regions and trigger collapse. An active black hole can heat surrounding gas and prevent it from cooling into new stars or drive outflows that reshape the inner galaxy. A galaxy is full of causes that become effects, that become causes again. That makes the black hole in Messier 77 more than an object at the center. It is part of a feedback loop. Gas feeds the black hole. The accretion process releases energy. That energy affects gas and dust. Those changes may influence future feeding and star formation. The system regulates itself imperfectly, violently, over enormous time. There is no master plan. There is only physics, but physics can create patterns that feel almost intentional. A spiral galaxy channels material inward. A black hole converts infall into radiation. Dust hides and reveals. Stars ignite in compressed arms. The entire structure persists for billions of years, not because it is static, but because motion is organized. Like a whirlpool, a galaxy keeps its form through flow. The whirlpool analogy is useful, but only up to a point. In a sink, water drains downward. In a galaxy, stars are not draining into the center. Most stars orbit for ages. The black hole is not a cosmic vacuum cleaner. That misconception is hard to kill because black holes sound irresistible. In reality, if the Sun were replaced by a black hole of the same mass, Earth would not be sucked in. It would keep orbiting, though the lack of sunlight would end life quickly. Gravity at a distance depends on mass, not on whether the mass is a star or a black hole. A supermassive black hole can shape the central region because it has enormous mass concentrated in a small volume, but it does not reach out and swallow the entire galaxy. Messier 77's black hole is powerful because material is available near it, not because it is pulling stars from the outer arms like dust into a vacuum. The feeding is local and selective. Gas must make its way inward through a long chain of dynamical steps. That is why active galactic nuclei can turn on and off over cosmic time. The black hole may always be there, but the fuel supply changes. A sleeping engine can wake. This raises a quiet question about our own galaxy. The Milky Way's central black hole is currently faint compared with active nuclei, but evidence suggests it may have been more active in the past. Large structures, such as the Fermi bubbles, seen in gamma rays above and below the galactic plane, may be linked to past activity from the galactic center or intense star formation. The Milky Way is not a perfect comparison to Messier 77, but the broader message is clear. Galactic centers have histories. Quiet does not mean always quiet. We live in a galaxy with a black hole at its center. That sentence has become familiar, which is dangerous, because familiarity makes impossible things feel ordinary. A black hole 4 million times the mass of the Sun sits in the direction of Sagittarius, hidden behind dust from our point of view, traced by the motions of stars whipping around an invisible mass. We are not threatened by it. We are far away, about 26,000 light-years from the center. But it is there. It is part of our address. Messier 77 shows what a more active version of a galactic nucleus can look like. It is a mirror, not of our immediate danger, but of a possible state of galactic life. A reminder that the central black hole is not an ornamental fact. Under the right conditions, it can become one of the brightest engines in the galaxy. The word engine keeps returning because it is precise. An engine converts energy from one form into another. In a car, chemical energy becomes motion and heat. In a star, nuclear binding energy becomes light and heat. Near a black hole, gravitational potential energy becomes radiation, particle motion, and sometimes outflows. The engine has no pistons, no metal, no designer. Its parts are space-time, plasma, magnetic fields, and matter forced into orbit by angular momentum. And unlike human engines, it can operate on scales large enough to illuminate a galaxy. When astronomers observe an active galactic nucleus, they gather evidence across many wavelengths. Optical spectra reveal emission lines from gas. Infrared observations reveal warm dust. X-rays can show extremely energetic regions near the accretion flow. Radio observations can trace jets or outflows in some systems. Each wavelength shows a different layer. No single image is the whole truth. This is why Webb is so important, but not alone. Webb adds infrared clarity. Hubble provides visible and ultraviolet views. Chandra observes X-rays. ALMA studies cold gas and dust at millimeter wavelengths. The Very Large Telescope and other ground observatories measure spectra and fine structures. Modern astronomy is not one telescope replacing another. It is a network of instruments building a multi-layered portrait of objects too complex for one kind of light. Messier 77 has been studied for decades because it rewards this approach. Each new instrument changes the question. Early observers asked what kind of nebula it was. Later, astronomers asked why the nucleus was so bright. Spectroscopists asked what gas velocities and ionization states were present. Infrared astronomers asked how dust concealed the center. Interferometers asked how compact structures were arranged near the nucleus. Webb asks what the warm dust and starlight look like, with a new combination of sensitivity and resolution. Science does not simply replace old answers. It refines old questions until they become sharper. The recent image is part of that long refinement. It does not reveal a black hole as a black sphere. It does not show the event horizon. It does not prove by itself everything we know about active galaxies. But it gives a visually powerful, scientifically useful view of a system where the central engine and the host galaxy are entangled. The danger in public astronomy is that images become trophies. A telescope releases a beautiful view. People share it for a day. The image passes through feeds. It becomes a background. Then attention moves on. But each image is a doorway. Messier 77 is not only beautiful, it is a question. What is a galaxy, really, when its center is hidden by dust and powered by a black hole? How much of what we see in the universe is surface? How often are the calmest structures masking violent processes? The universe is full of objects that look simple because we are seeing them from too far away. A star looks like a point, but it is a nuclear furnace. A nebula looks like a cloud, but it is chemistry, radiation, and shock. A galaxy looks like a spiral, but it is an ecosystem of gravity and feedback. The deeper astronomy goes, the less the universe resembles a collection of things, and the more it resembles a collection of processes. Processes do not sit still for portraits. Even the light in the Webb image is old. If Messier 77 is roughly 45 to 47 million light-years away, then the light arriving now left that galaxy tens of millions of years ago. On Earth, when that light began its journey, our own world was in the Eocene epoch. Mammals were diversifying. Continents and climates were different. No human eye existed to receive the photons. They crossed intergalactic space through ages of Earth history, only to strike the mirrors of a telescope at Lagrange point 2. The image is recent, the event is ancient. That is one of astronomy's quiet distortions. News from space is almost always old light. A new image is new to us, not new to the object. Messier 77, as it appears in Webb's image, is a record of the galaxy as it was millions of years ago. The galaxy today, in its own local present, may have changed in ways we cannot know yet. The active nucleus may be brighter, dimmer, differently fed. Stars have formed and died since that light left. Dust has shifted. Gas has moved. We are always reading delayed messages. And yet those delayed messages are enough to reveal laws. Gravity did not change during the journey. Atomic spectra did not forget their fingerprints. Infrared light still carries information about dust and heat. The universe is distant, but not unknowable. That balance defines astronomy. Distance and knowledge, darkness and inference, beauty and measurement. Messier 77 sits in the constellation Cetus, a region of sky associated with the sea monster in Greek mythology. The nickname Squid Galaxy adds another layer of creaturely imagination. Its arms curl like tentacles, and its center glows like a hidden eye. These names are human decorations, but they help the mind hold the object. We name distant things because otherwise the scale is too empty to think about. But the galaxy itself is indifferent to names. It was not waiting to be called M77. It did not become NGC 1068 when it entered another catalog. It is not actually a squid, or a monster, or a lamp. It is a rotating mass of stars, gas, dust, dark matter, and a central black hole, obeying physics in a part of the universe we can only touch with light. Dark matter belongs in the story too, even though Webb's image does not show it directly. A spiral galaxy's visible stars and gas do not contain all the mass needed to explain the motions astronomers observe. Galaxies are embedded in dark matter halos, extended structures of unseen mass that influence rotation and formation. The spiral disk is the luminous part. The halo is the larger gravitational environment. Messier 77, like other large galaxies, is not just what shines. This is one of the hidden layers behind every galactic image. The stars trace part of the system. Dust traces part of the system. Gas traces part of the system. The black hole dominates a tiny central region. Dark matter shapes the broader gravitational context. A galaxy is never only the visible galaxy. The phrase invisible universe is not poetry. It is measurement. Webb is not designed to detect dark matter directly. It sees infrared light, but by showing how visible matter behaves, it helps place luminous structure inside the larger invisible framework. Galaxy evolution is always the story of both seen and unseen mass. Gas falls into dark matter halos. Stars form in the densest regions. Black holes grow in galactic centers. Mergers rearrange the system. Feedback changes the gas supply. The image is luminous, but the full explanation requires what the image cannot display. That is another reason Messier 77 fits this channel. It looks like a picture of light, but it leads toward darkness. A black hole that cannot be seen directly. Dust that hides the center. Dark matter that shapes the galaxy. Infrared wavelengths beyond human sight. Ancient light arriving late. Telescope artifacts masquerading as beams unless you know how to read them. The image is an invitation to distrust the obvious. At first glance, the central brightness seems like the object. Look longer, and it becomes evidence of something deeper. The black hole is not visible. The accretion flow is partly hidden. The diffraction spikes are not real beams, the colors are translations. The beautiful spiral is a moving system. The image teaches skepticism without killing wonder. That is rare. A good astronomical image does not simply make the universe look pretty. It trains the mind to ask what is producing the light, what is blocking the light, what instruments shape the light, and what remains unseen. Consider the core again. The central black hole in Messier 77 is often described as supermassive. The word is accurate, but it can become numb with overuse. Supermassive means millions to billions of times the mass of the Sun. The black hole in Messier 77 is estimated at roughly millions of solar masses, commonly discussed near the range of several million to around 10 million solar masses depending on method and model. That mass is compressed inside an event horizon far smaller than the galaxy, yet its gravitational influence near the center organizes matter into one of the most energetic environments in the local universe. Mass alone is not the full story. Feeding matters. A larger black hole with little fuel can be dim, a smaller one with abundant fuel can blaze. The brightness of an active nucleus depends on accretion rate, geometry, dust, magnetic fields, and viewing angle. This is why black hole astronomy is not just a matter of weighing monsters, it is a matter of understanding their surroundings. A black hole in a vacuum is a locked door. A black hole in gas is a power station. The gas near an active nucleus becomes plasma, a state where electrons are separated from atoms. Plasma responds to magnetic fields. It twists, streams, heats, and radiates. Magnetic fields can transport angular momentum through the disk, allowing matter to move inward while some energy and momentum move outward. Under some conditions, magnetic structures can help launch jets or winds. Not every active galaxy shows the same kind of jet, but outflows are central to the story of many AGN. Messier 77 is especially associated with obscuration, ionized gas, and a compact active nucleus. The details are complex, and the exact geometry is studied through many instruments. What matters for the listener is the layered picture. A black hole. An accretion region. Dust around it. Gas being energized. Radiation escaping in some directions more easily than others. The galaxy around it, still forming stars and rotating in a larger disk. A central engine inside a dusty house, inside a spiral city, inside a dark halo. That image is closer to the truth than the simple phrase galaxy. The term Seyfert galaxy also deserves a little patience. Seyfert galaxies are a class of active galaxies with bright, compact nuclei and characteristic emission lines. They are often divided into types: based on which emission lines appear broad or narrow in their spectra. Broad lines suggest gas moving very quickly close to the central engine. Narrow lines come from gas farther out or seen under different conditions. In the unified model, some differences arise from orientation and obscuring dust, though real galaxies also vary in power, structure, and environment. This is one of the ways astronomers turn light into geometry. A spectrum is not a picture, it is light spread by wavelength. But inside it are clues about motion. If gas is moving quickly, its emission lines can broaden, because some parts move toward us and some away. If gas is ionized by intense radiation, particular atoms emit at particular wavelengths. If dust absorbs certain light, the spectrum changes. From a line on a detector, astronomers infer speed, temperature, composition, and location. The universe is generous with evidence, but it rarely labels it. You do not see a tiny sign that says black hole. You see gas moving too fast around too much mass in too small a region. You see radiation from hot accreting material. You see dust heated by a source hidden from direct view. You see emission lines from ionized clouds. You combine the clues until the invisible object becomes unavoidable. That is how black holes entered science. They were not accepted because they sounded dramatic. They were accepted because different lines of evidence converged. Stellar mass black holes in X-ray binaries. Supermassive black holes in galactic centers. Gravitational waves from merging black holes. The Event Horizon Telescope imaging horizon-scale structure around M87 star and Sagittarius A star. The orbits of stars near the Milky Way's center. The physics move from speculation to measurement. Messier 77 belongs to that measured universe. Its active nucleus is not fantasy. Its central engine is not a metaphor. The beauty of the image rests on hard evidence gathered across decades. Yet the emotional effect remains strange. A black hole lighting up a galaxy sounds like a contradiction. A thing famous for darkness produces one of the brightest regions in its host system. This is the kind of contradiction physics loves. The event horizon is dark. The matter outside it is not. The black hole removes light from within its boundary, but its gravity creates conditions outside the boundary, where matter can radiate intensely before crossing. Darkness makes the lamp possible. That is why the working title lands, "There is a black hole lighting up this galaxy." It is not literally the black hole shining. It is the gravitational environment of the black hole. But the paradox is real enough to be poetic. The darkest object in the system makes the center bright. There is something almost unsettling about that. Human instinct often links light with safety and darkness with danger. Astronomy rearranges that symbolism. A bright nucleus can be violent. A dark cloud can be a nursery. A black hole can power radiation. Empty-looking space can contain dark matter. The universe does not share our emotional categories. It simply works. The Webb image of Messier 77 also reminds us that telescope images are acts of interpretation. Raw data from a space telescope does not arrive as a finished cosmic painting. Detectors count photons. Instruments measure wavelengths. Data must be calibrated, cleaned, aligned, and assigned colors. Cosmic rays and noise must be handled. Multiple filters may be combined. The final image is both scientific and aesthetic, made to reveal structure. This does not make it fake. A medical scan is also processed. A radio map is processed. A photograph from a phone is processed. The question is not whether data are processed. The question is whether the processing preserves truthful relationships and reveals meaningful features. Webb images are translations, and good translations can be honest even when they are not literal. A galaxy seen in infrared and colored for human eyes is like music written in a key our ears can hear. The original signal is not visible to us. The translation lets the mind receive it. In Messier 77, this translation brings forward dust and starlight in a way visible light images cannot. Dust becomes structure rather than just absence. Warm regions reveal themselves. The core's intensity stands out. The galaxy becomes less like a flat spiral and more like a layered atmosphere of matter. There is a temptation to say Webb sees through dust. Sometimes that is partly true, but not always. Infrared light can penetrate dust better than visible light at certain wavelengths, yet dust can also be opaque in infrared if it is dense enough. Some infrared light comes from dust itself. So Webb is not simply looking through a curtain, it is also seeing the curtain glow. That distinction matters. The dust is not just blocking the real story. The dust is part of the story. It is the material that hides the active nucleus, reprocesses radiation, traces gas flows, and helps shape star formation. In a galaxy, the veil is also a character. The same is true of darkness. Astronomy often treats darkness as absence. But darkness can mean many things. It can mean there is no light. It can mean light is blocked. It can mean light is outside the wavelengths our eyes see. It can mean the object emits weakly but has mass. It can mean the signal is too faint or too old or too redshifted. In Messier 77, darkness appears as dust lanes, hidden central regions, and the black hole itself. Each darkness has a different cause. A mature view of the universe must distinguish them. That is one reason long-form science matters. A short clip can say, Webb saw a black hole lighting up a galaxy. That is a good hook. But the real satisfaction comes from unpacking the layers. The black hole is not seen. The light comes from accreting gas. The galaxy is a Seifert. The distance is roughly tens of millions of light years. The spikes are artifacts. The dust hides and glows. The spiral is active, evolving, and chemically rich. The image is recent. The light is ancient. The deeper story does not weaken the hook. It makes the hook true. When we talk about galaxies as living structures, we also have to talk about time. A human life is too brief to watch a galaxy evolve directly. But astronomers overcome this by looking at many galaxies at different stages, like studying a forest by observing seeds, saplings, mature trees, dead wood, and soil all at once. The analogy is imperfect because galaxies are not all the same species following one path, but the principle works. By comparing many systems across distance and time, astronomers reconstruct evolution. Some galaxies are gas-rich and star-forming, some are quiet and red, some are merging. Some have active nuclei, some show tidal tails from gravitational encounters, some are compact early galaxies from the young universe, some are massive ellipticals with old stars. Each object is a frame from a film too long to watch. Messier 77 is one frame, a nearby active spiral with a bright core. It tells us that a galaxy can have ordinary-looking outer regions and extraordinary central activity. It tells us that dust and orientation matter. It tells us that black hole feeding can coexist with star formation in the host. It gives astronomers a place to test models of active nuclei at a level of detail impossible for more distant objects. There is a practical reason to study nearby active galaxies. Distant quasars are powerful but hard to resolve. Their light can overwhelm their host galaxies. Nearby Seiferts are less extreme but more detailed. They are laboratories where the same underlying physics can be examined with finer spatial resolution. Messier 77 is valuable because it is near by cosmic standards and famous for its active center. A laboratory does not have to be on Earth. Sometimes a laboratory is a galaxy whose light left before humans existed. The image also draws attention to a question that still troubles astrophysics. How do supermassive black holes grow together with their galaxies? The earliest quasars in the universe already contain enormous black holes at surprisingly early times. Galaxy bulges and black hole masses show correlations in the nearby universe. Active feedback appears important in simulations, yet the pathways are not simple. Black holes grow by accretion and mergers. Galaxies grow by gas inflow, star formation, and mergers. The timing, regulation, and causal relationships remain active fields of research. Messier 77 is not a complete answer, but it is one piece of the puzzle. It shows how a central black hole can be embedded in a complex host, obscured by dust, and still announce itself through radiation. It gives a local view of a process that may have been much more common or more powerful during earlier cosmic epochs, when galaxies had more gas and black holes were growing rapidly. The nearby universe contains echoes of the young universe. That is why studying a galaxy tens of millions of light years away can help us think about galaxies billions of light years away. Physics scales, gravity scales, accretion scales, dust physics scales, not perfectly, not without context, but enough that local systems can act as Rosetta Stones for distant ones. There is a humility built into this work. Astronomers cannot fly to Messier 77. They cannot lower a probe into the accretion disk. They cannot collect dust from its nucleus. They receive photons, some infrared, some optical, some X-ray, some radio. They compare those photons to models. They argue about geometry, temperature, and motion. They improve instruments. They test again. From Earth and near-Earth space, we infer an engine 45 million light-years away. That should feel impossible. The fact that it works should feel even more impossible. The Webb telescope itself is part of the wonder. A segmented mirror unfolded in space. A sun shield the size of a tennis court, keeping instruments cold. A spacecraft operating around the second Sun-Earth Lagrange point, roughly 1.5 million kilometers from Earth. It was built to study the infrared universe, from early galaxies to star-forming regions to exoplanet atmospheres. Its images of nearby galaxies are not side quests. They are essential because galaxy evolution is one of its core missions. Webb's power is not only distance, it is sensitivity and wavelength. For Messier 77, that means the telescope can reveal structures shaped by dust and warm material near an active nucleus. It can complement older observations and make the galaxy feel newly legible. The object was famous before Webb. The image did not create the mystery. It illuminated it in a new way. That is often how science advances, not by finding entirely new things, but by seeing known things with a better instrument until they become unfamiliar again. The moon was familiar before spacecraft. Mars was familiar before rovers. Jupiter was familiar before probes. The Milky Way was familiar before radio astronomy revealed its hidden structure. Messier 77 was familiar before Webb. Then Webb looked, and the familiar galaxy became strange. A good telescope restores strangeness to the known. There is also an emotional reason galaxies captivate us. They are large enough to make human conflicts feel absurd, but they are structured enough to avoid pure emptiness. A galaxy is not just vastness. It is form. It is a pattern the mind can hold, even while knowing the scale is beyond comprehension. Messier 77 adds unease to that beauty. The pattern has a heart, and the heart is not a star. It is a black hole feeding on matter. Imagine standing on a planet in the outer regions of that galaxy, if such a planet exists around one of its stars. The night sky might contain a Milky Way-like band of starlight, depending on location. The central region might be hidden by dust or bright in certain wavelengths. Life there, if it existed, might never know the full nature of the nucleus without astronomy. It might see only a sky. Underneath that sky, the galaxy's center would be roaring in wavelengths, beyond unaided vision. We know our own sky in the same incomplete way. Most of the Milky Way center is hidden from visible view by dust. Ancient cultures saw the bright river of the Milky Way, but not the black hole. Even now, when we know Sagittarius A star exists, it is not visible to ordinary sight. Our galaxy's engine is inferred. We live inside a structure we cannot see from the outside. That makes external galaxies precious. They show us shapes we cannot directly observe in our own home. Messier 77 is both another galaxy and a lesson in how to imagine ours. From inside the Milky Way, we see dust lanes, star fields, and the band of the disk. From outside, perhaps we would see a barred spiral with arms and a central bulge. We would see star-forming regions, gas clouds, satellite galaxies, and a central black hole. We might judge it peaceful, but inside everything would be moving. No galaxy is peaceful from within physics. There are quiet zones. There are stable orbits. There are planets where oceans could persist for billions of years. Peace exists locally, but the larger structure is dynamic. Stars are born. Stars die. Gas falls. Black holes feed. Gravity never stops rearranging the furniture. The mistake is to confuse visual stillness with physical stillness. A photograph freezes motion. A long-exposure galaxy image freezes a system that is rotating, forming, heating, cooling, and evolving. The spiral appears still because the exposure is short compared with galactic time. The same would happen if you photographed a hurricane from deep space with an impossibly brief exposure. The storm would look like a shape. But the shape is motion. Messier 77 is a storm held in a spiral. Its central activity is not separate from the rest of the galaxy in the way a lamp is separate from a room. It is connected through gas supply, dust, gravity, and feedback. The scale of those connections is still being studied. But the principle is solid. The nucleus and the galaxy are parts of the same system. This has changed the way astronomers think about cosmic history. Early models could treat galaxies as collections of stars. Then gas became central. Then dark matter halos became essential. Then black holes became part of the story. Now galaxy evolution involves all of these at once. Stars alone cannot explain galaxies. Gas alone cannot explain galaxies. Black holes alone cannot explain galaxies. Dark matter alone cannot explain visible structure. The universe builds complexity through interaction. A galaxy is an argument between components. Dark matter provides the gravitational scaffolding. Gas cools and falls. Stars ignite and return energy. Dust mediates light and chemistry. Black holes grow and release energy. Mergers disturb or transform. Environment matters. Time matters. What we call a galaxy is the temporary balance of these forces. Temporary does not mean brief. A galaxy can persist for billions of years. But over cosmic time, it changes. The Milky Way and Andromeda are expected to merge in several billion years. Star formation rates rise and fall. Gas supplies are used, heated, or stripped. Black holes grow. Spiral structures can be disrupted. Elliptical galaxies can form from mergers. The universe is patient, but not static. Messier 77's current form is one phase. The light web sees is one era in that phase. Future astronomers, if they exist, and if they look from a different place in time, may see a changed nucleus, altered star formation, or a different dust geometry. The galaxy is not posing forever. Even the central black hole has a history. It did not begin as millions of solar masses in its present form. Supermassive black holes likely grow from smaller seeds through accretion and mergers, though the exact nature of the earliest seeds remains debated. Some may have formed from the remnants of massive first stars. Others may have begun as direct collapse black holes from large gas clouds in the early universe. The details matter for explaining how very massive black holes appeared so early. The black hole in Messier 77 is a descendant of that ancient growth problem. Its present feeding tells us about current conditions, but its mass contains a long past. Each bit of mass added over cosmic time came from somewhere. Gas. Stars disrupted. Mergers with other black holes. Accretion episodes now lost to history. A black hole is dark, but its mass is a fossil record of everything it has consumed. That thought is hard to make comfortable. At the center of a galaxy, an object with no surface, no light of its own, and no memory in the human sense, carries the accumulated result of ancient infall. It has grown by erasing the separate identity of matter. Atoms, plasma, perhaps stars, all crossing into a region where their future paths point inward. The event horizon is not a material surface, but it is a boundary in destiny. Outside it, matter can still speak in light. That is the key to active galaxies. Before matter disappears, it announces itself. It glows. It heats dust. It ionizes gas. It may be flung outward in winds. The final silence is preceded by brilliance. Messier 77's core is bright because matter is still outside. A black hole only becomes observationally dramatic when the universe leaves enough material near the edge to make a scene. That scene is what Webb sees indirectly. The black hole itself remains the invisible cause. This distinction protects us from myth. Black holes are not cosmic mouths eating everything. They are regions of space-time. Their drama depends on environment. In a gas-rich galactic center, the environment can be spectacular. In emptiness, the black hole can be nearly silent. The same object can be monster or ghost, depending on what surrounds it. Messier 77 surrounds its black hole with enough matter to make it a beacon. The word beacon appears often in descriptions of active galactic nuclei, and it fits. But a beacon usually guides someone. This beacon guides no ships. It is not meant for us. It is a side effect of gravity and matter. We use it as a guide because we are the ones trying to understand. The universe is not sending a message, but light carries information whether or not anyone intended it. The Webb image is a message without a sender. That is true of all astronomy. The photons do not know they are evidence. The dust does not know it is revealing temperature. The gas does not know its spectral lines betray its speed. The black hole does not know its gravity has written a signature across the nucleus. Knowledge is something the observer builds from indifferent signals. There is intimacy in that. Across 45 million light-years, a galaxy gives itself away. Not all at once, not easily, not in visible light alone, but with patient instruments and careful interpretation, the hidden structure becomes partly knowable. That is perhaps the deepest comfort in science. The universe is not designed for us, but it is intelligible in places. And then, just when it becomes intelligible, it becomes stranger. The black hole at the center of Messier 77 is not the only thing shaping the galaxy. Star formation is happening in the surrounding structures. Young stars heat nearby gas and dust. Massive stars flood their neighborhoods with ultraviolet radiation. Some will explode as supernovae, injecting energy and heavy elements back into space. The galaxy's arms are not merely decorative curls. They are regions where density, motion, and matter combine to make new suns. This coexistence is important. A galaxy can feed a black hole and form stars. Those processes can compete, cooperate, or regulate each other depending on circumstances. Gas that goes into stars is gas not going into the black hole. Energy from the active nucleus can heat or expel gas. But gas inflow can feed both central star formation and the nucleus. The relationship is not simple. Nature rarely respects clean categories. We want to label a galaxy as active or star-forming, quiet or violent, young or old. Real systems often blur those divisions. Messier 77 is a spiral galaxy with an active nucleus and star-forming regions. It is not one thing. It is several processes overlapping. This is why one image can carry so much meaning. The core points to black hole accretion. The dust points to obscuration and interstellar material. The arms point to disk dynamics and star formation. The overall shape points to gravitational organization. The distance points to cosmic time delay. The infrared view points to the limits of human sight. The optical artifacts point to the role of instruments. The name points to the history of astronomy. A galaxy is never just a galaxy. It is a meeting place for almost every major theme in astrophysics. Gravity builds the structure. Electromagnetism shapes light, plasma, and magnetic fields. Nuclear physics powers stars. Atomic physics creates spectral lines. Thermodynamics governs heating and cooling. General relativity defines black holes. Chemistry builds dust and molecules. Dark matter shapes the halo. Observation science translates photons into evidence. Messier 77 is not an exception. It is a reminder that the universe does not divide itself into school subjects. The central black hole belongs to relativity. The glowing gas belongs to plasma physics. The dust belongs to chemistry and stellar evolution. The spiral arms belongs to galactic dynamics. The image processing belongs to optics and data science. The emotional response belongs to us. All of it is one object. This is why long episodes about single topics work. A single galaxy can become a doorway into the structure of reality. You do not need to jump from object to object to find depth. The depth is already there if you stay. So stay for a moment with the fact that Messier 77's light left before humans existed, crossed intergalactic space, entered the solar system, passed near Earth, reached a telescope parked in deep space, reflected off gold-coated mirror segments, entered infrared instruments, became data, became an image, and then became a question on a screen. What are we actually seeing? We are seeing matter arranged by gravity. We are seeing old starlight. We are seeing warm dust. We are seeing a central region energized by accretion. We are seeing the fingerprint of a black hole without seeing the black hole. We are seeing the instrument as well as the object. We are seeing the past. We are seeing only light, but from light we infer mass, motion, and hidden structure. That is astronomy in one sentence, seeing only light and learning what does not shine. The unsettling part is how much of the universe fits that pattern. We learned about Neptune from gravity before direct confirmation. We learned about black holes from motions and radiation before images. We learned about dark matter from gravitational effects. We learned about exoplanets from tiny dips in starlight and stellar wobbles. We learned about cosmic expansion from redshifts. Again and again, the universe reveals itself indirectly. Direct sight is overrated. The eye wants objects. Science often gets traces. Messier 77 is a trace-rich galaxy. It leaves clues in dust, spectra, infrared glow, and nuclear brightness. Each clue says the same thing in a different language. The center is active. The galaxy is not a static spiral. Something compact and massive is shaping the heart of the system. The black hole does not have to be visible to be undeniable. That may be one of the most important lessons of modern science, and not only astronomy. Reality is not limited to what appears directly. The unseen can govern the seen. Fields, forces, dark matter, space-time curvature, radiation beyond the visible, microscopic structures, quantum states, all of them shape experience without presenting themselves as ordinary objects. The galaxy becomes a philosophical instrument. It teaches that what looks peaceful may be active. What looks bright may be caused by darkness. What looks like a picture may be a process. What looks like empty space may contain the conditions that make everything visible possible. There is a black hole lighting up this galaxy. That line sounds like a contradiction, because human language was not built for the universe. It was built for human-scale objects. Fires burn, lamps shine, holes are empty, darkness hides. But in the physics of an active galactic nucleus, a hole can make a region bright. Darkness can reveal itself by heating dust, and emptiness can have geometry strong enough to decide the fate of matter. We should expect our words to strain. The universe is under no obligation to stay within metaphors. Still, metaphors help. The galaxy is a city. The black hole is an engine. Dust is a veil. Infrared is a hidden language. The image is a fossil of light. Each metaphor catches something and loses something. Used carefully, they let us approach scale without pretending we have mastered it. The moment a metaphor becomes too comfortable, science has to break it. A black hole is not really an engine made of parts. A galaxy is not really alive. Dust is not really a curtain. Infrared light is not really sound. But each image opens a door, and through the door we can describe the physics more clearly. Messier 77 asks for that balance. It is beautiful enough for poetry and measurable enough for equations. The equations matter even when we do not write them down. Orbital motion near a massive object. Radiative transfer through dust. Ionization balance in gas. General relativity near compact mass. Magnetohydrodynamics in plasma. Stellar evolution in star-forming regions. The image is the surface of an enormous mathematical structure. And yet, to the listener at night, it may begin simply. A galaxy far away has a bright center. That is enough to enter. From there, the path leads inward. Why is the center bright? Because gas is heating. Why is gas heating? Because it is falling and orbiting near a massive object. Why does it not fall straight in? Because it has angular momentum. Why does it radiate? Because collisions, turbulence, magnetic fields, and acceleration convert gravitational energy into light. Why is some of it hidden? Because dust surrounds the central region. Why can Webb see more? Because infrared light interacts with dust differently than visible light. Why does this matter? Because active nuclei influence galaxies and reveal how black holes grow. One question opens another. That is the proper rhythm of curiosity. Not a rush to answers, but a descent through layers. The deeper we go, the more Messier 77 becomes a map of invisible relationships. The nucleus affects the dust. The dust shapes the light. The light shapes our inference. The inference changes the model. The model guides the next observation. The next observation reveals another layer. Science is not a straight line. It is an orbit slowly losing altitude around the truth. Perhaps that is why active galaxies are so compelling. They combine the largest structures we can imagine with the smallest boundaries we cannot cross. A galaxy tens of thousands of light years across. A black hole event horizon measured on a scale tiny by comparison. The huge and the compact, tied together by gravity. The center matters because it is small and extreme. The disk matters because it is large and complex. The image matters because it lets both occupy the same frame. In everyday life, we tend to associate importance with size. Bigger things matter more. Astronomy often disagrees. A compact remnant can shape a nebula. A neutron star can produce beams visible across the galaxy. A black hole's immediate surroundings can outshine its host. Tiny dust grains can decide whether visible light escapes. Small things, under extreme conditions, become cosmic. Messier 77 is a lesson in concentrated consequence. The black hole is not large compared with the galaxy, but the energy released near it can be enormous. The dust grains are tiny. But together they hide the nucleus and reroute radiation into infrared. The telescope mirror segments are small compared with the galaxy beyond all comparison. But they gather the photons that let us know anything at all. Scale is not hierarchy. Sometimes the smallest boundary changes the largest view. There is another unsettling thought hidden here. If many galaxies have central black holes, and many black holes have active phases, then the universe is full of hidden engines. Some are blazing now. Some have gone quiet. Some may wake later. Some are buried behind dust. Some are aimed in ways that make them appear different to us. The sky is not just stars. It is a population of machines built by gravity. Some of those machines are dormant. Dormant is not dead. A dormant black hole waits only for fuel. A galaxy merger can disturb gas and drive it inward. A passing cloud can be captured. A star can wander too close and be torn apart in a tidal disruption event. The quiet center can flare. The calm can change. This does not mean we should fear the center of every galaxy. Fear is usually the wrong response to scale. But awe without accuracy becomes superstition. The better response is alert wonder. The universe is stable enough for life in places, but dynamic enough to make complacency absurd. We exist in a calm pocket of a violent cosmos. Messier 77 makes that visible. Its central engine does not threaten Earth. 45 million light-years is not neighborhood in any practical sense. Its radiation is part of the sky, not a danger to us. But as an object of thought, it changes the way we picture galaxies. It makes the familiar spiral shape less innocent. A spiral can have teeth. The teeth are not in the arms. They are in the center, in the invisible mass, in the dusty structures that hide what is happening, in the high-energy radiation escaping from compressed matter. The galaxy curls beautifully around a place where space-time has become a one-way door. This contrast is the essence of cosmic unease. Beauty wrapped around violence. Light caused by darkness. Calm shape produced by restless motion. An image that looks like art but functions as evidence. There are many ways to approach Messier 77. The historical way begins with Messier and Messier. The observational way begins with telescopes and spectra. The physical way begins with accretion and dust. The philosophical way begins with the gap between appearance and reality. The Webb image lets all of these approaches meet. It is a modern image of an old mystery. When Charles Messier cataloged the object, he did not know it was another galaxy. When Carl Seifert studied bright galactic nuclei, the black hole paradigm was not yet what it is today. When infrared astronomy developed, dust became less of a wall and more of a signal. When Webb launched, it carried decades of engineering and expectation into a cold orbit. Each generation inherited a blur and made it sharper. The universe did not change. Our questions did. That is the quiet miracle of science. The object remains far away, indifferent, and ancient. The mind moves closer. One day, future telescopes may show Messier 77 in even more detail. They may map the dust near the nucleus with greater precision, trace gas flows more clearly, separate star formation from AGN heating more completely, and test models that today remain uncertain. Webb is not the final eye. It is one eye in a long chain. Every telescope is temporary. Every discovery becomes a foundation. But some images endure because they teach the public a new way of seeing. Messier 77 may do that for galaxies. It may help people stop thinking of them as static islands and start thinking of them as living structures in the physical sense. Systems with histories, engines, weather, and hidden interiors. That shift matters. When the public imagines a galaxy as static, astronomy becomes a museum. Beautiful objects, fixed in place, labeled, and admired. When the public imagines a galaxy as dynamic, astronomy becomes a story of transformation. Matter circulates. Stars ignite. Black holes grow. Dust hides and reveals. The universe becomes less like a gallery and more like an ocean. Not calm water, deep water. Cetus, the whale, is a fitting place for this galaxy in the human sky. A sea creature in a dark celestial ocean, holding within it a spiral called the Squid Galaxy, lit by a black hole hidden in its depths. The names are accidental, but the mood is right. Something vast moving under the surface, something luminous below the waves, and us, at the shore, reading ripples. There is also a moral humility in the image. Our civilization can build an infrared telescope and unfold it in space. We can analyze light from another galaxy. We can infer a supermassive black hole from signatures no human senses evolved to perceive. That is extraordinary, but we still receive only traces. We still depend on photons that happen to arrive. We still argue with models. We still cannot touch the object. Knowledge is powerful, but not possession. We do not own Messier 77 by naming it. We do not tame the black hole by explaining accretion. We do not make the galaxy safe or simple by turning it into an image. Understanding is not conquest. It is a more honest form of wonder. The best science leaves the universe larger than it found it. At the end of this path, the original image remains: a glowing center, swirls of dust, a barred spiral galaxy in Cetus, a black hole hidden inside the brightness, diffraction spikes from the telescope, infrared light translated into color, ancient photons made new to us. But now the image is heavier. You can see the core and think of gas falling inward. You can see the dust and think of dead stars seeding future stars. You can see the spiral and think of density waves and star formation. You can see the spikes and remember that instruments leave signatures. You can see the brightness and know it comes from a dark center. That is what learning does. It adds weight to beauty. The galaxy no longer floats as decoration. It works. It burns. It conceals. It evolves. And somewhere inside it, behind dust and radiating gas, there is a boundary from which no future light will ever return. Around that boundary, matter makes one last bright announcement before disappearing from the observable universe. Perhaps that is why active galaxies haunt us. They show that disappearance is not always quiet. Sometimes the approach to darkness is the brightest event in the room. Messier 77 is not empty. It is not still. It is not merely pretty. It is a galaxy with a hidden engine, a galaxy whose center exposes the strange bargain between gravity and light. The black hole takes, and the taking makes the galaxy shine. We are left with an open question not only about Messier 77, but about galaxies as a whole. How deeply do central black holes shape the lives of the galaxies around them? Are they minor actors that become important only during feeding episodes? Or are they regulators woven into the long history of cosmic structure? The answer is still being assembled, photon by photon, image by image, spectrum by spectrum. For now, we can say this much. A galaxy is not a frozen island of stars. It is a system in motion. And at least in Messier 77, the heart of that system is a darkness bright enough to announce itself across tens of millions of light years. Subscribe to Dark Matter Radio for more long-form science. Leave a comment with the question this galaxy leaves in your mind. Stay curious, stay awake, and keep listening to the dark.